welcome back. Today we are on 12.2, adding and subtracting polynomials. Page 657. Money. You're saving for a trip to Costa Rica, obviously after the travel ban is lifted. You deposit $500 into the bank account that earns an interest compounded annually. 1 year later, you deposit an additional $600 into the account. Let R be the annual interest rate. What is the balance, A, of the account 2 years after the initial deposit? In example 2, you will see how to solve this problem by adding polynomials. Remember from last lesson, a polynomial is just the addition of multiple monomials. So term 1 plus term 2 plus term 3. So multiple terms in one expression is a polynomial. You add polynomials by combining like terms. One way to add polynomials is to align like terms in columns. If one polynomial is missing a term, you either leave a space in that term's column or write the term with a coefficient of 0. So let's look at example 1. Find the sum. I wrote both A and B on the board. A is negative 8x cubed plus 4x squared plus x plus 1, all is one expression, plus a second expression of 3x cubed minus 2x plus 7. And so what the instructions above said is you add polynomials by writing them in columns of like terms. If your expressions are missing a like term, you just leave a blank there, or you could put a 0. So starting here, our first term is negative 8x cubed. Look at your second set of parentheses. Do you have any other terms that are x cubed? Yes. We have 3x cubed. So I'm going to bring it over, and I'm going to put it underneath it to form my column of x cubes. I have 3x cubed. So now I can kind of cross that off. I'm done there. My next expression is going to be 4x squared. So I'm looking at my second set of parentheses to see if I have an x squared. And I do. I have a negative 2x squared. So now I'm going to bring it over and create a column of my x squareds. Next term, single x's. Look to my second set of parentheses. I have no terms with a single x. So now you can either leave a blank or just write in a 0. I have none of them. Nothing's going to be added there. And then finally, I have a whole number 1. Do I have any other whole numbers to add to the column? Yes, I have a positive 7. And now I'm going to add all of these together. Negative 8x to the third plus 3. Negative 8 plus 3 is 5. Tack on your coefficients. So I have 5x to the third, or not your coefficients, tack on your variables. You add your coefficients, tack on your variables. Moving over to my next one, 4x squared plus negative 2x squared. 4 plus negative 2 is just going to be a positive 2, so plus 2. Tack on your variables, x squared. Now, x plus 0, or if you left a space, just x. X plus 0 is just x. Bring it down. And then our last one is our whole numbers. 1 plus 7, that's 8. So after we added both expressions, so the both sets of parentheses together, we're left with this as our final answer. 5x cubed plus 2x squared plus x plus 0. Notice we don't have an equal sign, so we're not solving for x, we're just simplifying the expression. So one more time, for B, we have 2 sets of parentheses, and we're adding the 2 expressions together. Our first set of parentheses is 2x to the fourth plus 6x to the third minus 5x squared plus x minus 7. That is just one expression. The parentheses are what separate your expressions. What are we adding to it? We're adding the second set of parentheses. Inside the second set of parentheses, we have x to the third minus 3x squared plus 2x plus 1. And what we're going to do is we're going to take every term in the second set of parentheses and stack it underneath its like term from the first set of parentheses. So our first term is 2x to the fourth. So we're going to look at our second set of parentheses and see if we have any matching x to the fourths. We look. We don't. The highest value in the second set of parentheses is x to the third. So there are no x to the fourths to be added there. So we're just going to put a space there or a 0. Next, we're looking for x cubed and we have a single x cubed right here. So we're going to add x cubed. Next we look for x squared. We have a negative 3x squared. So we're going to add a negative 3x squared underneath the x squared column. Now we're looking for our x's. We have a 2x. We're going to add our 2x. Then we have the whole number 1. Remembering that we're adding this whole expression together. 2x to the 4th plus 0 is just 2x to the 4th. 6x to the 3rd plus x to the 3rd. Remember you have a hidden 1, and you're just adding your coefficients, the number in front of your variable. So 6 plus 1 is 7x cubed. Negative 5x squared plus negative 3x squared, you're just adding your variable, your coefficient. So negative 5 plus negative 3 is going to be plus a negative 8x squared, or you can just write minus 8x squared. Now we're on to our x's. X plus 2x, remember your hidden 1. 1 plus 2 is 3, so plus 3x. And then lastly, our whole numbers, negative 7 plus 1. 7 plus 1 is going to be negative 6. And that's going to be your final answer. So after you combine your two expressions, you're left with 2x to the 4th plus 7x cubed minus 8x squared plus 3x minus 6. Flipping the page, we're going to skip example 2 for the sake of time, and we're going to move to example 3. Subtracting polynomials. You can subtract polynomials by adding their opposite. So subtraction is really just the addition of a negative number. So they're saying if you're going to subtract polynomials, just add the numbers opposite of the second term. So take your second term, or your second expression, your second set of parentheses, change all of the signs in it, then just add them together, same as we did over here. To find the opposite of a polynomial, multiply each of its terms by negative 1, or you literally just switch the signs. You can subtract polynomials vertically or horizontally. So we're going to look at that. Alright, example 3. We have, find the difference of 6x squared plus 4x minus 7 as our first expression. Then we're subtracting it from a second expression, which is 2x squared minus x plus 8. Alright, the instructions about this problem said to find the difference, which is subtraction, of two terms or two expressions. Just add the opposite of every number in your second expression. So what that means is we're going to add the opposite of everything here. So I originally had a positive 2x squared. Change it to the opposite of negative 2x squared. I originally had a negative x, so I'm going to make that a positive x. I originally had a positive 8, so I'm going to make that a negative 8, and now I'm going to add it to my first expression. And I'm going to do the same thing. I'm going to create my columns of like terms. I'm going to take negative 2x squared and put it under my 6x squared. So negative 2x squared plus 8, or not plus 8, plus x. So I'm going to add my x minus 8. And now I've just created columns of my like terms, and I'm going to add them. Plus negative 2 is going to be 4, tack on your variable, x squared, plus x plus, or 4 plus x, remember that hidden 1, so 4 plus 1, 5x, 7 plus negative 8 is going to be negative 15, and I found the difference of these two terms. So again, what did I do? I took my original expression, I changed subtraction to addition, and I took the opposite of every number and rewrote it. After I rewrote it as the sum of the opposite of my second expression, I took my terms and I created my vertical columns of like terms, and then I just added them. And then this is my final answer, and that is called your your vertical stacking. And then example 4 is all about how do you subtract polynomials horizontally. I don't recommend this method. This is much easier, but I'll show you anyways. But example 4. We have x squared plus 4x minus 9, x squared plus 4x minus 9 is being subtracted by 4x squared minus 5x plus 11. Yep. Okay, so then you say, what do? We write the difference as the addition of the opposite of every number in the second term, or second expression. So rewrite your first one, x squared plus 4x minus 9, change this to addition, plus, and now write the opposite of every number in your second set of parentheses. So I originally had a positive 4x, now I have a negative 4x squared, I originally had a negative 5x, now I have a positive 5x, I originally had a positive 11, now I have a negative 11. And so I rewrote subtraction as addition with the opposite of every number. Next, I am going to look for my like terms and I'm going to combine them. X squared, negative 4x squared. So what is x squared plus 4x squared? It is going to be negative 3x squared. And I brought those like terms together. Next, I'm going to look for just my single x's. I have 4x and 5x. What's 4x plus 5x? 9x. Those are taken care of. And now I'm going to look for my constants. I have negative 9 and negative 11. Negative 9 plus negative 11 is going to be negative 20. And now that's my final expression once I bring it all together. And that is 11.2. You are now welcome to start your homework.